Yeah, there are two. Yes, when you reconstruct from the left or from the right, you are doing it's different. It's a different linear function. That's right. Yeah, that's not completely correct. So we're not reconstructing the solution. So in finite volume, we never reconstruct the solution as a continuous function. We only try to reconstruct the solution at specific locations from the cell averages. So in finite element, we are going to have the notion of an entire solution function. But either in finite difference or in finite volume, we do not actually reconstruct the solution as a function at all. We only look at infinite difference, we only look at the value of the function at specific points, or in finite volume, we look at the averaged function in the volumes and also reconstruct the value of the function at the specific points using the averages. So we never have a notion of the function itself in finite volume or finite difference. Yes. How do we reconstruct R at the boundaries? Okay, so good question. So if you reconstruct the so I guess the question is if you want to look at a boundary flux, right? The flux at the boundary. So reconstruction from the interior to the boundary is easy. It's the same thing as before. But at the boundary, you need information from the outside, right? So usually the outside boundary condition is computed by there are two possible ways. One possible way is the outside value is given to you. Okay, so it's at a particular value. Then you don't need any reconstruction because you have the value of the function immediately outside the boundary. The other case, let's see, what is the other case? The other case is when the characteristic is going out towards the boundary. So the characteristic is going outward, so you cannot specify any boundary condition at the boundary, right? In that case, you actually don't need the reconstruction from the outside because you know when you apply a Riemann solver, you'll be using the flux from the interior anyway. Okay, so either way, you can use the value of the boundary condition immediately outside. So you don't need any reconstruction. You don't need to apply a limit or reconstruction outside the boundary because you have the solution immediately outside the boundary. Does it make sense?
But we are actually defining this R as the rightmost cell. And we choose to just not include the next cell, that is a fictitious cell. We just choose to include the boundary.
Yeah.
Then can we actually compare the slope by defining the right slope as twice of URB minus the half value of the last cell?
Can you say again?
So if the last cell is the nth cell,
yeah.
Then what we can do is we can say that the slope that is coming from the right is U right boundary minus UN multiplied by 2. And then we can divide it by UN minus 1.
Oh, so I'm talking about okay, so I think what you're talking about is basically using the value at the boundary and the value in the first cell to construct a slope. Yeah, that is perfectly fine when the characteristic is going inward. When the characteristic is going outward, you can't really do that because you're not supposed to enforce a boundary condition at the outlet. So your value, so if you use a Riemann solver, the value you have in the first cell and the value you think you have the outside of the boundary is going to be completely different, and the slope you reconstruct is going to be horrible. So that means if you have a system of equations, some characteristics are going out, some are going in. So it's dangerous to reconstruct the solution using the boundary value. All right, hope that makes sense. Any other questions? All right. So that concludes our discussion on finite volume.